kind of problem you'll have for a heat problem, as opposed to just a temperature problem. Temperature problems is just, you're in Fahrenheit, you want to get in Celsius, or some combo like that. Okay, let's read this over. How much heat is required to raise the temperature of 205 grams of water from 21.2 degrees Celsius to 91.4 degrees Celsius? Okay, if I've got, let's think about this for a moment. If I have 205 grams of water, how many milliliters of water is that? 205, because the density is 1. It's only water that you get to make that direct switch. So I got 205 milliliters of water. Trent, how many mils do you have in that bottle of stuff? Does it say? 296. Okay, to give you some perspective, this thing full is 296 milliliters. We are taking 205 milliliters of water. 205 grams is 205 milliliters if this had been pure water. So what would that be? Maybe up to here? We're taking about this much water? About enough water to heat up to make tea, perhaps? Hot tea? And 21.2, that's about room temperature. So I'm taking a cup, about a cup, of room temperature water, and I want to heat it up to right below the boiling point. I don't want my tea too hot. And I want to know how many joules that's going to cost me to do. And anytime you're doing a temperature change like this, here is your needed equation. Another card. Okay, heat is equal to the mass of your substance. Doesn't it just make sense? You got more, it's going to take more to heat, more joules to heat it, times this constant, the specific heat, times the change in the temperature. Delta here means change, just like math people use it. Also, for us, absolute value of the change. Don't have negative numbers in here. That comes later in 1412. Specific heat. Yeah, specific heat. Okay, I discovered if I abbreviate both and have S, H, and delta T, it looks like a bad word to some folks. So I always put S and then heat. Did you catch what? Okay. All right, so I want to be careful. Okay, now, let's see what we have. Here's our equation that we need. Got it on a flashcard. Let's try it, and then I think you'll see the sense of why this thing works. Okay, so they're saying, how much heat? We're talking heat here, we're not talking temperature. No, that's the big clue. This is the equation we need. Okay, mass. Take a look up there. The mass that we've got, Marco, hit it. What is it?
205.
And give me some units.
Grams.
Grams. How many SIGs? 3. Okay, specific heat of water is a constant that we can look up. And so I put in 4.18, because this is liquid water. If they don't say something about gas or ice or something, then assume it's going to be liquid water, and the units are joules per gram per degree Celsius. And then we need the change in the temperature. So we need to look up there and get the change. Okay, and the change is, Timothy, can you tell us?
91.4.
91.4. Okay, watch before you start crunching numbers. Is that
Why is it not?
Okay. Oh, wait, yeah. Delta T, Timothy, the change in the temperature. So what would you have to do, Timothy, to get that? What do we need to do, Tanya?
Subtract the 21.2 from the 91.4.
And you got
70.2.
70.2. You see what she did, Timothy? It's the change. Delta means change in the temperature, not the temperature, the change. I think it's mathematically simpler to do out separately, do the change, and then slap it in there. Okay, a couple of things before we start crunching numbers. Let's do a unit analysis. Grams are on the top. Grams are on the bottom. Celsius is on the bottom, Celsius is on the top. What does that leave you with? Joules. That's what we want. That's a unit for heat. That is a wonderful security blanket there, or safety net, that we set it up right. Now, again, before you start crunching numbers, let's think about this. What is this thing telling us? It is telling us every time we have 1 gram of water, and I want to change it by 1 degree Celsius, I need 4.18 joules. But hey, today, I'm not taking just 1 gram of water. I'm taking 205 times that. So doesn't it just make sense to multiply? Okay, then over here, I don't want to change it just 1 degree. I want to change it a whopping 70.2 degrees. So 70.2 times more. So that says, hey, go multiply. Our unit analysis tells us to go multiply, and our reasoning through tells us to go multiply. Because this is for 1 gram, 1 degree Celsius, and you seldom want to do just that. So we're going to multiply this, and we're going to think 6. We already know about units. Pedro, what'd you get?
60,154.
60,154. Okay, is that what other folks got? But we want to think 6. Nina, how many 6 do I want in this answer?
3.
3, because 3, 3, 3, 1, 3. Now, Nina, could you take that and round it for me so it's 3?
Would it be 601? No, 602, I'm sorry.
602, end of story? You just changed size on me a whole bunch. Didn't I tell you that story about somebody that weighs 128 pounds, and I want their weight to 2.6? Some of my students will say that, well, hey, I weigh 13. I don't think so. Don't change magnitude. Okay, you got 602, but what can you give me?
0.00.
Yeah, put in a point, you change size, don't you?
60200.
Ah, perfect. Okay, now, trick question. Should I put a decimal here?
No.
Okay, why not? Nicole, why not?
Change your number of somethings.
Perfect. If I put a decimal there, we just went back to having 5.6. We don't want 5.6, we want 3.6. Okay, so 602. And good, this is 5 or greater. Up we go. So that turns that into a 2. Okay, so 6,200 joules. Now let's play a couple of games with this. Okay, I decide that's a big enough number. Scientific notation would be appropriate here. So let's switch that over. Hina, tell me what to write.
6.02 times 10 to the 4th power.
Of joules. And that's a fine answer. Or, I look at this, I decide I don't like joules, I would like kilojoules. Because we can switch, with the metric system, we can do anything. Antonio, how many? I hear somebody whispering to him. Okay, joule would be the basic unit in heat, and I want you to go to there. How many kilojoules?